Okay, Nana. So let's take problem number 1 only. Already we have done this sum as per Vogel's, northwest corner method. Now we're gonna do the same problem as per Vogel's approximation method. Okay. So what is the method name? Vogel's approximation method. What is the method name, Nana? Vogel's approximation method. Okay, let's put the matrix first and then we'll start solving. So this is your matrix, right, Anna? So we have warehouse 1, warehouse 2, warehouse 3, factory 1, factory 2, factory 3. So you have 6, 8, 4, then you have 4, and 9, 8, 1, 2, and 6. Okay, so we have supply 14, 12, 5, and then you have demand. So it is 6, 10, 15. Okay, chalo. Now this total is 31, this total is also 31. Now this is the question. Now before we start solving, you need to understand that whether it is balanced and is it a minimization sum, similar to assignment, same conditions, both the conditions needs to be satisfied. Now first condition is what? Is it a minimization? Obviously the first problem is minimization because nothing has been mentioned in the question and we can presume that it is a minimization problem. You got it? Second, is it balanced? Yes, it is balanced. How? Because supply total is equal to demand total. Then it is balanced. It has got nothing to do with number of rows and number of columns. Just by equating the supply total with demand total, you can say whether it is balanced or not. Is that clear? So now both the conditions are satisfied. Can we solve? Yes, we can. Now what we are going to do is that we are going to do row operation and column operation simultaneously. Not it is exactly not same to what we have done in assignment, little bit different. First you follow the procedure, then I'll explain you the logic. Okay. First let's go with the procedure. Now follow the procedure, Nana, carefully, then I'll explain you the logics behind them. Okay. Follow the procedure now. What do you have to do? Select the least cost, that is 4. Next least cost, that is 6 in the first row. Take the difference, that is 2. Again, least in the second row, 4. Next least, 8. Take the difference, 4. Next least is 1. Next least cost is how much? 2. What is the difference, Nana? 1. So now row operation is done. Now do the same for column operation as well. In the first column, take the least, which is 1. Next least, 4. So what is the difference? 3. Least, 2. Next least, 8. What is the difference? 6. Least, 4. Next least, 6. What is the difference? 2. Is that clear? Now out of this, you need to select the you need to select the highest of the differences. What do you need to select? Highest of the differences. Now who is highest here? 6. So we need to select this one. So here what we're going to do is that 6 represents this second column, correct? Which is W2. In W2 column, we need to select the least cost possible. Who is the least cost? 2. So I will start allocating for 2. You have 10 here, you have 5 here. Supply is 5, demand is 10. Whichever is less. Whichever is less means I'll go with 5. So 5 will become 0, 10 will become 5. Correct? If 5 becomes 0, this entire row is gone. Therefore, you cancel it off. This entire row is gone. Is that clear, Nana? Now again, we'll do the second time. We'll repeat the steps. So first let me start with row operation. First row, again it is the same because the least cost is 4, next least cost is 6, therefore the difference is 2. Second row, again it is the same because the least cost is 4, next least cost is 8, so which means the difference is 4. And this one is gone because already it has got finished. The entire supply is gone, okay, from factory 3. Now coming on to columns. Now this entire third row is gone. So now you look at the first column, you are left with 6 and 4. So least cost is 4, next least cost is 6. So what is the difference? 2. Second column, least cost is 8, next least cost is 9. So what is the difference? 1. Least cost is 4, next least cost is 8. So what is the difference? 4. You got the point? Now tell me which is the highest of the lot. There is a tie. So you have two fours here. When there is a tie, what you have to do, listen carefully. When there is a tie, normally we need to select the highest of these differences. But when there is a tie, what you have to do? Take this 4. Take this 4 and you see in this column, take this 4 and you see in this column how much you will be selecting this 4, correct? Because in this column this is the least one And for this least cost, how much is the allocation made, right? So you can take this particular 4 and this 4 will be the least cost. If you take this particular 4 also, again 4 is the least cost. So again there is a tie. Normally what will happen, suppose here if it is 5, suppose here it is 5. So in this, if you select this 4, the least cost is 5. If you select this 4, the least cost is 4. Then I'll go for this 4 because the least cost is 4 here. So 4 is better when compared to 5. But unfortunately in this sum, there has been double tie. Already there is a tie in differences. 4 4, here there is a tie. Again if you go for this 4, you are going for 4 again. If you go for this 4 also, you are going for 4 again. So again there is a tie. So when there is a double tie, what do you have to do? See where you can give maximum allocation. For example, if you select this 4 and you select this 4, okay, what is the allocation you can give? 14, 15. So 14 and 15, whichever is less. So 14. Here the allocation will be 14. Whereas if you select this 4, you will go for this 4, correct? So in this 4, what will happen? Demand is 6 and supply is 12, which means how much is the allocation that you will give? 6 only. Therefore, I'll select that 4 where I can give maximum allocation. Therefore, I'll select this one. Therefore, here I'll give an allocation of 14, 15. I'll give 14. 14 becomes 0. 15 will become 1. When 14 becomes 0, this entire row is gone. Is that clear? Now you are left with one row. Remember, whenever there is only one row or one column left over, you can directly allocate. Again, I repeat, whenever there is one row or one column which is left over, directly you can allocate. So which means what I can do here, 6 is there, so allocate 6 here, 6 becomes 0. Here 5 is there, give 5 here, 5 becomes 0. Here 1 is there, give 1 here, 1 becomes 0. 6 plus 5 plus 1, it's going to be 12, so 12 becomes 0, everything is gone. Is it clear, Nana? So we are done with the first step. Now, whatever the solution that you have got now after the first step, we call it as IBFS. What is IBFS? Initial basic feasible solution. Is that clear? Now, so IBFS. What is IBFS that we have got? I'll just repeat the matrix here. 3 rows and 3 columns. Okay, what you have got, Nana? 6, 8. For 4, there's an allocation of 14. Okay, then for 4, there is an allocation of 6. 9, there is an allocation of 5. 8, there is an allocation of 1. 1, 2, there is an allocation of 5. 6. This is the matrix, right? Which we have solved. Correct? Now, this is nothing but initial basic feasible solution. This is nothing but what, Nana? Initial basic feasible solution. If you look at the question, he has asked you obtain the IBFS for the following. We have already done it. We have already obtained the IBFS. And look at the question. Look at the question. And also determine whether they satisfy the optimality test or not. So which means now I have to go for optimality test. Now how to do optimality test? Before going for optimality test, there is one more thing. What is that? You need to check whether is number of allocations is equal to m plus n minus 1. What is number of allocations? 1, 2, 3, 4, 5. 5 allocations is equal to m means number of rows 3 plus n means number of columns 3 minus 1. So 5 is equal to 5, which means now I can proceed for optimality test. You understand the point? Now you can proceed for optimality test. Now you can ask me, then what is this, sir? Maybe you can call it as test for optimality test. Okay, it is one test for another test. You got the point? So I got my first solution, that is nothing but initial basic feasible solution. And I want to find whether this is the best solution or not. That's why I do optimality test. Now before going for optimality test, you need to do another test. So that another test is nothing but number of allocations is equal to m plus n minus 1. So which means it is like, maybe you can call it as test for optimality test. You got the point? Now, is number of allocations is equal to m plus n minus 1? Yes. 5 is equal to m is number of rows plus n is number of columns minus 1. So therefore, when 5 is equal to 5, now we can proceed for optimality test. Okay, chalo. Now, how to do this optimality test? Let me write the heading, optimality test. How to do this optimality test? Very simple. First, you'll have Cj, then you'll have something called Zj, then you'll have something called Cj minus Zj. Don't worry about this naming terms and all. In one book, it will be different. Is that clear? Depending upon that particular author. So Cj is nothing but the solution that you have got. Okay. Let me write that solution first. Cj is nothing but the solution that you have got. Okay, what is the solution you have got? 6, 8, 4, you have 14, 4, you have 6, 9, you have 5, 8, you have 1, 1, 2, you have 5, and then you have got 6. So this is the solution now we have got here. You can check it in the previous slide. This is the solution that you have got. That is Cj. Then what is Zj? Now listen carefully. What is Zj? Let me put the matrix first. Let me put the matrix, okay? Zj. Okay. Now let's try to understand what is Zj. Very simple. First, what do you do? Select all the numbers from allocated cells in Cj. What do you have to do? Select all the numbers from allocated cells in Cj. So what are the numbers from allocated cells, Nana? 4, 4, 9, 8, 2. Correct? All these are allocated cells. Yes or what? Alright. So did you copy? Yeah, finished. Next, what do you have to do? Presume one variable to be 0. Here I have presumed 0. Can you see that? Here I've presumed 0. Now what you do is that, can you see this white dot? Now you follow this white dot carefully. Can you see this white dot? So you follow this dot carefully. So that's my mouse, okay? You follow this mouse very carefully, right? Now see here. I have presumed 0 here. Okay, now you need to observe carefully. See here. Something, I've put a question mark. Something plus 4 is equal to 0. Something plus 4 is equal to 0. What is that something? Minus 4. Correct? Something plus 4 is equal to 0. What is that something? Minus 4. Now minus 4 plus 8 is equal to something. Minus 4 plus 8 is equal to something. So minus 4 plus 8 is equal to 4. Correct? Now something plus 9 is equal to 4. Look at my arrow mark. Look at my arrow mark. The dot is there now, white dot. You observe that only. Something plus 9 is equal to 4. Something plus 9 is equal to 4. It should be what? Minus 5. Correct? Now minus 5 plus 2 is something. Minus 5 plus 2 is something. It should be minus 3. Minus 4 plus something is minus 3. It has to be 1. Correct? Minus 4 plus something is minus 3. It has to be what, Nana? 1. Is it clear? Minus 4 plus something is minus 3. It has to be 1. Next. Minus 5 plus something is 0. 5. Okay. Next. Something plus 4 is 4. 0 plus 4 is 4. Correct? Something plus 4 is equal to 4. 0 plus 4 is equal to 4. Next. 0 plus something is minus 3. 0 minus 3 is minus 3. 0 plus something is 0. 0 plus 0 is 0. Got the point, Anna? Now, let's go for Cj minus Zj. Don't worry if you don't get it for the first time. We're gonna solve this nearly 10 times before we finish off this chapter. By the times we solve it 10 times, you'll get it. Nobody gets it right the first time itself. Is that clear? So don't worry. Now, what is Cj minus Zj? Very simple. Now, once you're done with Zj, you underline all the unallocated cells. What are the unallocated cells? 6. For that, the corresponding is 0. So it's an unallocated cell. For 8, the corresponding is 5, which is unallocated. This is unallocated. This is unallocated. Correct? All these are unallocated cells. Correct? All these are unallocated cells. Now what do you have to do? Pretty simple. Cj minus Zj. So in Cj you have 6 here. In Zj you have got 0 here. So 6 minus 0 is 6. Next, 8 minus 5, 3. Next, 1 minus of minus 3, 4. Next, 6 minus 1, 5. So 6, 3, 4, 5. So all the numbers in Cj minus Zj are non-negative. Non-negative means what, Nana? It should be either 0 or positive. Is it non-negative? Yes. You have only 0 or positives here. There are no negatives. Therefore, the IBFS what you have got is the best solution. The IBFS what you have got initially is the best solution because it has satisfied the optimality test. Now, why did we do optimality test? To check whether the solution that we have got is the best solution or not. And we have done that optimality test by way of 3 steps. That is Cj, Zj, Cj minus Zj. Once you have non-negative values in Cj minus Zj, it means the initial basic feasible solution or the answer that you have got is the best solution. Therefore, this will be the best solution. Is that clear? This is the IBFS that you have got. This is the best solution. So therefore, your final answer will be 4 into 14 plus this is 4 into 6 plus this one 9 into 5 plus this one. 8 into 1 plus this one. 2 into 5. You got the point, Nana? So I think it comes around 143. You see? As per northwest corner method, your least cost was 228. As per Vogel's approximation method, the least cost is 143. Now you can understand which is a better method. So that northwest corner is absolutely crude method. You got it, Nana? Now don't worry about the step of CJ minus ZJ, Nana. Nobody gets it right the first time. Even I did not get it. So now you have just listened once. Anyway, you can listen to each video 3 times. You can listen it again and again. And by the time we finish off this whole chapter, you would have been doing this at least some 10 times. Once you have done 10 times, it will get to you. Okay. So don't worry about that. Right, Nana? So with this, we'll finish off this session. Thank you.